So we'll see some more questions related to kinematics. So this is how the question is. I'll read it out. A ship moves along the equator to the east with velocity v naught equal to 30 kilometers per hour. The southeastern wind blows at an angle 60 degree with the equator with the velocity v is equal to 15 kilometers per hour. And that angle that it makes with the equator is phi equal to 60 degrees. Find the wind velocity v dash relative to the ship and angle phi dash between the equator and the wind velocity, wind direction in the reference frame fixed to the ship. Now it's very clear from this question that suppose the first and the foremost step in this kind of question is we draw a simple map of directions: north, south, east and west. Right? This is how the directions are, and say there is this earth. Okay, I'm just drawing this for imagination purpose. And this is the equator. It's actually, we can consider that it is a straight line, and the ship moves like this with a certain velocity v naught, and that velocity v naught is equal to 30 kilometers per hour. And then there is this wind, which it says, the question says it's a southeastern wind. Southeastern wind means that the wind blows from southeastern direction. So this is south, this is east, this is southeast. So southeastern direction means this is this direction, and the wind blowing from southeast direction means the wind blowing from here. So the direction of the wind is like this. Okay. And it also says that the wind blows at an angle at 60 degree with the equator. The wind is like this, and the angle that the wind makes with the equator is 60 degrees. Okay. So if you just draw a vector diagram for the velocity vectors, we have two velocity vectors out here. One is v0, the velocity of the ship, and the other is v. V is the velocity of the wind. And these vectors are such that this angle is 60 degrees. Now what it says, find the wind velocity v dash relative to the ship. That's the first part of the question. So what is v dash now? Relative velocity concept. Relative velocity of the wind with respect to the ship will be equal to velocity of the wind minus velocity of the ship. That's the first thing that we know about this entire problem. The second thing that they have asked in this question is the angle phi dash between the equator and the wind direction in the reference frame fixed to the ship. So this question basically means that you are considering the reference frame which is fixed to the ship, and then you are trying to figure out what is the wind velocity vector and what that vector, how much angle that vector makes with the equator. So in the reference frame fixed to the ship, how will the wind velocity vector be like? What will be its magnitude, and what will be the angle that that particular vector makes with the equator? This is all that this entire question is all about, right? Now this v dash is when we want to find out the relative velocity of the wind with respect to the ship. It's the velocity of the wind minus the velocity of the ship. And when we want to find out the angle between the equator and the wind direction in the reference frame fixed to the ship, what it basically means is that the angle that the relative velocity of the wind with respect to the ship, what angle that makes with the equator is what we have to find out. So what it basically means is we just have to do a vector summation of this and find out what is the magnitude of that vector and the angle that that resultant vector will make with the equator. That is all that we have to find out here, right? So we already know that this angle is 60 degrees. We already know that, the way to find out the resultant of two vectors is just add up their respective components, or and then calculate the square of the x components and the y components, right? So here we have this vector and this vector. So this, if you consider the y direction, which is this direction, this is the y direction. In the y direction, v0 does not have any component because this direction is the direction which is perpendicular to the equator. v0 is along the equator. This is perpendicular to the equator. This is wind which is at 60 degrees to the equator as per the information given in the question. Now the perpendicular component of v will be v sine 60, right? And the perpendicular component of v0 will be nothing, right? So the perpendicular component of the resultant will be v sine 60, because there is only one vector which has a perpendicular component or a component along the y-axis, or if you can call this as y-axis, there is only one vector which has a certain component along that axis. The other vector is perpendicular to this particular axis, so it does not have any component along that axis. So if you call the resultant as say VR, then along the y-axis the component is V sine 60, and if you call the resultant x component as VRX, that will be equal to V cos 60 plus V naught. Now this plus is very important out here, because you are doing a minus of these two vectors. Had it been an addition of this vector, things would have been different, right? If we were doing a V vector plus V naught vector, it would have been different, but we are not doing a V plus V naught vector. We are doing a V minus V naught. So if since we are the x component of V and V naught are in opposite directions, we have to add it up, because we are finding out the relative velocity. So when say there are two particles A and B and they are traveling in opposite directions, and suppose if you want to find out the relative velocity of B with respect to A, you have to add up the velocity of B and A. Why? Because they are traveling in the opposite directions. If A and B are traveling in the same direction, and then you have to find out the relative velocity of B with respect to A, that will be VB minus VA. So if the velocity vectors are in the same direction, to find out the relative velocity, you subtract the relative velocity, the actual velocity, and in case the velocity vectors are in the opposite directions, in that case when you want to find out the relative velocity of one with respect to the other, you have to add the velocities. So this is the y component of the relative velocity vector. This will be the x component of the relative velocity vector, right? All that you have to do is plus V R x whole square. Okay, let's not take it as tan theta. We can take it as tan theta is equal to V R y divided by V R x. Right? So we have all the values that we need to find out VRY and VRX. Now VRY is, I am saying that's the resultant velocity. And when I say resultant, I mean this minus this, the resultant of this vector minus this vector, right? Or there is one more way of looking at it. This plus minus this. So this plus minus this will be equal to, just turn the vector opposite in the opposite direction. We can think of it like this. This V will be like this. Minus V naught will be like this. So V plus minus V naught, right? You can just shift the vector like this. So it will be something like this. The resultant, right? So VR is just V vector minus V naught vector. So when you want to find out the V vector minus V naught vector, you have to just subtract the x components and the y components, and in case they are in the same direction, here as far as the y component is concerned, when I say y component, I mean this axis. When I say y component, V naught does not have any component along the y axis, only V has a component. That component is equal to V sine 60. So the resultant vector, where the resultant is a vector subtraction of V and V naught, will have along the y a component of V sine 60. The x component will be equal to V cos 60 plus V naught. You have to add it up, because this velocity is in this direction, this velocity is in this direction. So since the velocities are in the opposite direction, you have to add up. Tan theta, it's not visible, so I just write it out again. then theta will be equal to VR by VRX. As simple as that, right? So we have all the values. We need to find out VRY, VRX. VRY will be given by V sin 60. V we know is equal to 15 kilometers per hour. V naught we know is equal to 30 kilometers per hour. So we can find out VRY, VRX. We can find out VR. We can find out the angle, right? So I generally leave my questions till the stage where all that you need to reach at the exact answer is just calculations, right? I generally do not do the calculations. So this is all that this we have to do in this question. It's a very simple question. It's a very basic question based on the concept of relative velocity. Now let's go to another question. Two swimmers leave point A on So the question is like this. Two swimmers leave point A on the one bank of the river to reach a point B lying right across on the other bank. One of them crosses the river along the straight line AB while the other swims at right angles to the stream and then walks the distance he has been carried away by the stream to get to the point B. What was the velocity u of his walking? If both swimmers reach the destination simultaneously, the stream velocity v0 is equal to 2 kilometers per hour and the velocity v dash of each swimmer with respect to water, this stands for with respect to water, is equal to 2.5 kilometers per hour. Now there are a few important things to understand here. Suppose if this is the river, okay, there are two swimmers. One swimmer crosses the river along a straight line AB. So the river is like this. It has water and the water is flowing in certain directions like this. And this swimmer starts off from a point A and then it reaches a point B, which as per the question is lying right across on the other bank, and this point A and point B are exactly, this line connecting them is exactly perpendicular to the direction of the flow of water. That's what it means actually, because it very clearly says that B is lying right across on the other bank. This is the bank of a river, and so is this. This is the water that is flowing in the river. This is the direction of the flow of the water. Now when it says one of them crosses the river along a straight line AB, like this, what does it mean? That this swimmer must have gone somewhere along like this, right? And that the river velocity must be like this, because we already know that the river velocity is like this. So the resultant vector must have been in the perpendicular direction. Yes, I have drawn it a little bit longer. It should have been like this actually, right? So the river velocity was like this, the swimmer velocity was like this, so that is why the resultant velocity was like this. And this resultant velocity was such that the swimmer swam exactly perpendicular to the flow of the river, right? So that the vectors are like this, This is the velocity vector of the swimmer, and this is the velocity vector of the river, and then this is the resultant vector. This is the velocity vector of the swimmer, this is the velocity vector of the river, and this is the resultant velocity vector. Now suppose if this angle was alpha, in that case we know that the horizontal component of the velocity vector will be equal to Vr, where Vr is the velocity of the river. So the horizontal component of this, suppose that the velocity of the swimmer is say Vs, or in fact V1, because there are two swimmers. So V1 is the velocity of the first swimmer and V2 we will take as the velocity of the second swimmer. So V1 cos alpha will be equal to Vr. I am using a different terminology because it's more suitable to me, but once we arrive at a solution we can just replace it with the terminology that is given here, right? So in this case cos alpha will be equal to Vr by V1. What is now, this part is a very important part of the question. What is the velocity of his walking if both swimmers reach the destination simultaneously? So one swimmer goes exactly like this, The second swimmer crosses the river along a straight. One of the swimmers crosses the river along a straight line AB, while the other swimmer swims at right angles to the stream and then walks the distance that he has been carried away to get to point B. The second swimmer goes like this. The velocity vector of the river is like this. So his velocity, resultant velocity vector, will be like this. So he goes in this direction and he reaches somewhere here. Now this and this are the same points. I am drawing it separately so that it becomes clear. It should not be there should not be too much of it should be clear what has happened. So this swimmer and this swimmer both start off from A. So I am drawing these vectors separately so that you understand what is happening for both the cases separately. It reaches like this. Then from here he travels in this way and then he reaches the point B. And it's been given to us in the question that the time taken by the second swimmer to go from here to here plus the time taken by the second swimmer to go from here to here is equal to the time taken by the first swimmer to go from here to here. Suppose if the time taken by the first swimmer is say T, what will be T? T by V sin alpha. D is the distance. We can just assume that the breadth of the river is say D. You already know the value of cos alpha. D by, this is V1, sin alpha is equal to 1 minus cos square alpha under root of that. This is the time T that we can say that the first swimmer needs to go from point A to B. Now let's come to the second swimmer. Second swimmer travels in two parts. One is the time taken for the second swimmer to go from here to here, and the second part is the time taken by the second swimmer to go from here to here. So let us say that the time from here to here is say T1, from here to here is T1, and from here to here is T2. So what is T1 now? D by V2. Why? This total distance is D. Now in the case of the second swimmer, there are two velocity vectors. One is this, which is the velocity of the swimmer, because we know that the swimmer travels at right angles to the direction of the river. So this vector will add with this vector to form the resultant velocity vector. So in the resultant velocity vector, the horizontal component or the component along the direction of the flow of the river will be only this, and the vertical component, the component perpendicular to the direction of the flow of the river, will be only the velocity of the swimmer. Velocity of the swimmer, suppose if we take that as V2, it's another issue that V1 and V2 are the same. We can do that later. So T1 will be equal to D divided by the perpendicular component of the resultant velocity vector. And what is the perpendicular component of the resultant velocity vector? This. Because this is a vector addition of this and this. And this is along the flow of the river. So this will not have any component perpendicular to the flow of the river. Although only this vector will have a component flow perpendicular to the flow of the river, because this component is perpendicular to the direction of the flow of the river, because the swimmer swims at right angles to the direction of the flow of the river as per the information given in the question. So this time that the swimmer takes to reach from here to here will be equal to D by V2, the perpendicular component of the velocity vector. This is the time that the swimmer requires to reach from here to here. In fact, the if we can say the displacement from here to here is, this is the actual value. So the y component of that displacement will be equal to this. Also, if we consider the time taken for the swimmer to walk from here to here, let us suppose that speed at which the swimmer walks, which is what we have to find out. Suppose that speed is Vf. Vf, I'm just taking like that because Vf is velocity that we want to find. Suppose this distance is dr. This is generally known as the drift. So when a swimmer is walking along or swimming across a river, if due to the flow of the river the swimmer gets carried away some distance, in this case the swimmer got carried away from this distance, and this happened because of the flow of the river. So this distance is known as drift. So Vf will be equal to drift by time taken, by time. So this will be drift by T2. T2 will be equal to drift by T2. Let's go to the next page. T2 will be equal to drift by Vf. Vf is the velocity that we want to find out. Now the question is, what is drift? Drift will be Vr into d by v2. Why d by v2? D by v2 is the time taken by the swimmer to reach from here to here. In the same time, the swimmer reaches from here to here. The horizontal displacement of the swimmer is this, which is what we want to find out. The vertical displacement, when the swimmer goes from this point to this point, the vertical displacement of the swimmer is this. The horizontal displacement of the swimmer is this, right? So now we want to find out the horizontal displacement of the swimmer. This will be equal to time taken for the horizontal displacement into the velocity of the horizontal displacement. Now, what is the velocity of the horizontal displacement? Vr, the velocity of the river. Because in the horizontal direction there is only one velocity vector working, that is Vr, the velocity of the river. And what is the time for this horizontal displacement? The same as the time for the vertical displacement, which is this. T1 is equal to d by v2. Right? So this is drift. So T2 will be equal to drift by Vf. So Vr into d by v2 to Vf. We know this. From this we know T1. We know T. You also know that T is equal to T1 plus T2, right? Time taken by both swimmers to reach at point B is same. So we just have to substitute all these values T1, T2, T in this equation. We know everything, that we just have to find out VF. D will get cut. We know VR, we know V2, we know V1. V1 is equal to V2 is equal to 2.5 kilometers per hour. VR is equal to V0 actually. Instead of V0 I was just using VR because VR, velocity of the river, appears to be simpler. So VR is equal to 2 kilometers per hour. So if we replace the values of this and this in this equation, D will get cut. The only thing that we have to find out is VF, which we can easily find out. I think I already said that I generally leave my questions at a stage where all that you have to do to come to the exact answer is rough calculations, right? Now let's see another question. So basically, this question is like this. Two boats anchored to a buoy move away along mutually perpendicular lines, boat A along the river and boat B perpendicular to the river. After moving equal distance, boats return to the starting point. Find the ratio TA by TB if the velocity of each boat with respect to water is 1.2 times greater than the stream velocity. Right? So, suppose this is the river. Say velocity of is VB. Velocity of water is VW. It has been given to us in the question that VB by VW is equal to eta. VB is the velocity of the boat and VW is the velocity of the water in the river or stream. Both the ships are traveling in mutually perpendicular directions. VB does not mean velocity of ship B. VB means velocity of the boat. Both velocity of both the boat A and boat B, I have taken that as VB. VB stands for B stands for boat. Okay, so don't get confused there. So these two ships are traveling in perpendicular directions. This is like this. This will go like this. It says boat A travels along the river and boat B perpendicular to the river. So let us suppose this is boat A, it travels along the river. Suppose it goes a distance say D. So TA will be equal to D by total time taken. Let us calculate the total time taken by this boat A to go from here to here and then from here to here. Now it has been given in the question that both the boats travel in equal distance in the directions in which they are traveling and then they return back to the starting point. So suppose this distance is D and this distance is D. So this boat, which is boat A, will go like this, it will come back. Boat B will go like this, it will come back. Right? The question is time for this boat A, to go like this and then come back. Divide that time by the time taken by the boat B to go like this and then come back. So we have to find out that ratio. So let us talk about boat A first. As we can see that the boat A, first it goes downstream because the velocity of the water is like this. So it goes downstream and then again it goes upstream. So when it goes downstream, the velocity, the time taken will be equal to D by VB plus VW. And when it goes upstream, the time taken will be equal to VB minus VW. Because downstream, the velocity of the boat and the velocity of the stream will get added because boat is moving in the direction of water. And upstream, the boat is moving opposite to the direction of water. So the net velocity will be VB minus VW. So the total time for the boat A to move a distance D downstream and then move back that same distance D upstream will be equal to downstream time plus upstream time. For boat B, we have to find out for boat B now. Now we know that, I think we discussed in the last question, that boat B travels perpendicular to the water. So for boat B, the velocity vector of the boat plus velocity vector of the water will add up to a vector which is perpendicular to the direction of the flow of the water. So it will be like this. I'll just do that once more because something was not completely visible, so I'll just do that once more. So if you take the example of this, we know this. Now for the boat A, the total time will be equal to downstream time plus upstream time. The downstream time will be equal to D by VB plus VW plus upstream time will be equal to D by VB minus VW. If D is the distance that the boat A travels along the direction of flow of the river, say this is D, so it goes D distance like this, and then again D, it comes back to its starting point. So total time will be equal to D by resultant velocity downstream, which would be equal to VB plus VW. VB is the velocity of the boat, VW is the velocity of the water, plus time taken to travel upstream. The distance is the same, D. So D by the velocity upstream, resultant velocity when it is traveling upstream. What is the resultant velocity when the boat travels upstream? VB minus VW, because upstream means the boat is traveling opposite to the direction of the flow of the water. So this is the total time that the boat takes to go downstream a certain distance and then back upstream the same distance. Now it's about TB, time taken by the boat B. This boat, it travels like this. Now if you see, it has been said that this boat B travels perpendicularly to the flow of the water. So it's obvious that this boat travels like this. The velocity vector of the river gets added to the velocity vector of the boat with respect to the water, and the resultant velocity vector will be like this. The velocity vector of the water is like this. So the resultant velocity vector is perpendicular to the velocity, the direction of the velocity vector of the river, which is why we say that the boat B travels perpendicular to the river. Actually, the boat B travels at an angle. Suppose if that angle is say alpha. So in this case, we know that VR, this is VB, suppose, will be equal to VB cos alpha. Why? Because we know that the boat is traveling at angle alpha and the horizontal component of that gets cut with the velocity of the river, which is why it travels perpendicularly to the flow of direction of the river. So the horizontal component VR is equal to VB cos alpha. Cos alpha is equal to VR by VB. So you have taken this as VR. You can say VR or VW, whatever. So this is VW by VB, which is equal to 1 by eta. So now, time taken to travel by that this boat needs to travel d distance like this and d distance like this will be equal to d by VB cos alpha. Time taken by the boat to travel from here to here is d by VB sin alpha. D by VB sin alpha plus the time taken by the boat to travel from here to here to here again is VB sin alpha This will be equal to 2d VB sine alpha TB. What we have to find out? TA by TB. This by this. You don't have to do anything, you just have to rearrange the terms slightly. D will get cut. You know the value of cos alpha, you can replace that with here. If you rearrange these terms, you will get sine square alpha somewhere, or in fact you will get sine alpha. Then sine alpha is equal to under root of 1 minus cos square alpha. So all that you have to do after this is this divided by this, and you will arrive at the answer. Answer is equal to -1. Slight rearrangement of these two terms is required, which is a very simple thing. I generally do not do such simple things actually. Let's take another question. So the question is like this: a boat moves relative to the water with a velocity which is n equal to 2.0 times less than the river velocity. At what angle to the stream direction must the boat move to minimize drifting? Drifting, I just told you what is drifting. Suppose if there is a river and say if a swimmer or any boat moves along the river in any direction, compared to this point, if it reaches the other bank on this point, this total distance will be the drift. So this drift. Okay. Now let's come back to this question. Suppose if VR is suppose if we consider the velocity of the river is VR and velocity of the boat is say VB. Alpha. Suppose we know boat moves relative to the water with a velocity which is 2 times lesser than the river velocity. So VR by VB is equal to N. Now, in this boat, there are two things, right? So the question basically means is, what should be this angle so that this drifting is minimum? I can draw another diagram, a bigger one, so that will be things will be clearer. I can draw it like this here, maybe. Okay. So this angle, like this, VB. VB stands for the velocity of the boat. VR is the velocity of the river. And suppose if the boat reaches somewhere here, this will be dr, drift. Now, what we need to understand out here is that there are two opposite things, right? The greater this angle alpha, the more will be the value of VB sine theta. Now for this velocity vector, if we divide this into two parts or two components along the direction which is perpendicular to the river and along the direction which is parallel to the river, this direction, and along the direction which is parallel to the river, this direction, you can call this as Vx and you can call this as Vy. Vy will be equal to Vb sin alpha. Vx will be equal to Vb cos alpha. Right? The greater this angle, the greater will be the value of Vb sin alpha. Right? The lesser this angle, the lesser will be the value of Vb sin alpha, because sin alpha will increase as alpha increases and sin alpha will decrease as alpha decreases. But it's the opposite way around for cos. Cos alpha increases when alpha decreases. So if this angle comes down, Vb cos alpha goes up. Right? Suppose we want to find out drifting. So drifting means this distance. So this distance will be equal to time by total velocity in the horizontal direction. Total resultant velocity in the horizontal direction will be equal to Vr minus Vx or Vr minus Vb cos alpha. You already know that Vr is double of Vb, n is 2. Vr is double of Vb. So Vr is more than Vb. Cos alpha is something less than 1. So Vr minus Vb will be something actually. And if suppose we want to find out what is the maximum value of this particular thing, this maximum value will come when alpha decreases. When alpha decreases, cos alpha will increase, and when cos alpha increases, Vb cos alpha also will increase. If Vb cos alpha increases, Vr minus Vb cos alpha will decrease, which is what we want. We want Vr minus Vb cos alpha to decrease. Why? Because we are interested in finding out what is the angle to minimize drifting. So if the horizontal component of the velocity is minimum, this distance traveled will also be minimum. Suppose if there is any particle which travels with a very less velocity, it's obvious that the distance traveled also will be quite less. If it travels with a very high velocity, obviously the distance traveled also will be higher. So if you want to find out what is the angle for which this drifting must be the minimum, one aspect of it is we will basically try to consider the angle for which cos alpha is the maximum In that case, Vr minus Vb will become minimum, and since the velocity is minimum, at that velocity the drift also will be minimum. That's one thing that we can say, but it's not exactly correct. That's one factor that influences drifting, but there is another factor also which influences drifting, and that factor is if you decrease this, cos alpha increases and this velocity comes down. But as you keep on decreasing this, sine alpha also decreases. As sine alpha decreases, Vy decreases. As Vy decreases, the speed along the direction perpendicular to the flow of water also decreases. And so because of that, there is always a chance that since it flows for a very long time, that's one factor which might lead to the drift getting larger. Right? So what I'm basically trying to say is, as alpha decreases, there is one reason to minimize the drifting, and as alpha decreases, there is another reason to maximize the drifting. So in this case, we have to find out the balancing angle at which the drifting is the minimum. We already know that Vy is equal to Vb sine alpha. What is this time taken? Say d by Vb sine alpha. What is drift? Say I call drift as say dr. What is drift? Vr minus Vb cos alpha into d. Oh, in fact, it should be the opposite way around actually. This equation should be Vb cos alpha minus Vr into d by Vb sin alpha. Not this, this is, I just wrote it in the opposite way. This will be the drift dr. This is equal to d cot x cot alpha d Vr by Vb cosec x, cos x alpha. This will be the value of the drift. And we already know that there is a way to find out at what angle this value will have a minimum value. Differentiate it and put that equal to 0, and you will be able to find out the value of the angle. If you differentiate this, what do we get? D cos x square x. Sorry, d cot x, it will be d cot x. plus cos x square x equal to 0. This is n also will be here. So if you solve this equation, you will get cot x is equal to 1 by n or 1 by 2. Oh, sorry, that cos x is equal to 1 by 2. So x is equal to 60 degrees. So angle with respect to the horizontal is 60 here, and this angle will be equal to 120 here. So after this point, all that we have to do is differentiate this with respect to alpha and put that equal to 0. That will give us the minimum. Okay, because we already know that there is something known as minima and maxima. So whenever we have to find out the minimum or the maximum value of any expression, we just have to differentiate it and put the differentiated thing to 0 and then solve the equation. So you'll get the value of x, which is what we've done here. We get x equal to 60 degrees.